Lesson 1.31 is on partial fractions, an introduction to partial fractions for GCE A-Level Pure Maths Year 1. In this lesson, we are going to learn how to decompose or split algebraic fractions into partial fractions. For example, 7x minus 3 over x plus 1 times x minus 4. If you were given this expression to integrate, it will be very difficult to integrate it as it is. But if you're able to split it into partial fractions, then it becomes easier. And that's one application of partial fractions. If you also ask to expand this, then it will be very difficult to expand it as it is. And so you have to resort to splitting the expression into partial fractions before applying the techniques of binomial expansion. So these are two applications of why we need to learn how to split fractions into partial fractions. In this first lesson, which is the first of a series on partial fractions, we are going to be dealing with fractions which have linear denominators. So for example, this is linear because this is in the form ax plus b, where in this case, the a is 1 and the b is also 1. In the case of x minus 4, the a is 1 and the b is minus 4. We are going to use two methods. The first method is known as the substitution method, and the second method is known as the comparing coefficients method. So if you're given this expression to resolve into partial fractions, you must have two component partial fractions as follows. And each of them must be a proper fraction. And here, this can be written as ax to the power 0 over x plus 1. But because x to the power 0 is 1, that's why this is the same as a over x plus 1. And that guarantees that this is a proper fraction, and that is also a proper fraction because the degree of the x here is 1 less than the degree of the x here. And so please note that the two fractions must be proper fractions. Please also note that this sign here is not an equal sign. It is an equivalent sign, which means that this side is the same as that side for all values of x. It is not like x squared plus 3x equals to 5, in which case this is an equal sign, and which means that there are only particular values of x which will make this equal to that. So for this case, the equivalent sign means that this side is equal to that side for all values of x. So now we're going to proceed with a decomposition, and we do that by multiplying each term, this term, this term, and this term by the denominator of this. So if I multiply each term by this denominator, I'll get something like this. And we can now see that x minus 4 will cancel with that, and x plus 1 will cancel with that. On this side of the equation, x plus 1 will cancel with that, and you'll be left with a times x minus 4. And for this term, x minus 4 will cancel with x minus 4, and you'll be left with b times x plus 1. And so we can proceed with our cancellation as follows. And now we will have the following. And so for the two methods, we are going to proceed in the same way until we get to this point. And this is where the similarities for the two methods end. So we are going to now start with the substitution method, and then after that, we are going to do the comparing coefficient method. So for one, the substitution method. So we start with the equivalent relationship we had before, and here we are going to do some convenient and strategic substitutions. That means if, for example, if I let x equals to 4, then 4 minus 4 equals to 0, and the whole of this term will be eliminated. And so now I can solve for b. So let's do that. So if I let x equals to 4, then I have 7 times 4 minus 3 is equals to 4 minus 4 times a plus 4 plus 1 times b. This will simplify to 25 is equals to 5b. Please note that I have now introduced an equal sign here because substitute a particular value, which in this case is 4. Now going forward, we can solve this for b, and we're going to get b is equals to 5. In the same way, if I let x equals to minus 1, then b will be eliminated. And so I have this situation here, and reduce that to get minus 10 equals to minus 5a, and solving for a means that I'm going to get a equals to 2. So the original expression can now be written as 2 over x plus 1 plus 5 over x minus 4. And so this is how we use the substitution method to resolve this particular algebraic fraction into partial fractions. The comparing coefficient method. Remember, the process is the same up to this point. So we're going to start with this relationship here. And so we have that. But this time, we are going to expand the right-hand side of this relationship. So if I do the expansion, I'm going to get that. Then I'm going to simplify by collecting like terms together. And then I'm going to introduce some brackets as follows. And now we can see that on the left-hand side, the coefficient of x is 7. And on the right-hand side, the coefficient of x is equal to a plus b. And the constant is b minus 4a. So we can now say that a plus b is equal to 7. And b minus 4a is equal to minus 3. So we have two equations that we can solve simultaneously. So we say comparing coefficients, a plus b is equal to 7. And b minus 4a is equal to minus 3. So these are two simultaneous equations that we can solve. And I prefer to write this equation here as b plus a equals to 7. And then I can write the second equation, which is b minus 4a equals to minus 3. If I now subtract, b minus b is nothing, and a minus 4a is 5a equals to 7 minus 3 is 10. If I solve for a, I'm going to get 10 divided by 5 equals to 2, just like the first one here. Now I can substitute the value of 2 in any of these equations to get a value of b. So if I use the first equation, I'm going to get b plus 2 is equal to 7. And therefore b is equal to 7 minus 2, and b is equal to 5 as before. So we now can write our algebraic fraction as 2 over x plus 1 plus 5 over x minus 4. And this is how we use the two different methods to resolve algebraic fractions into partial fractions. Now we are going to use the knowledge we have just acquired to answer two questions. Question 1. f of y is equal to 4 minus 2y all over 2y plus 1 times y plus 1 times y plus 3 is equal to a over 2y plus 1 plus b over y plus 1 plus c over y plus 3. Find the values of the constants a, b, and c. So you can see that it's possible also to have 3 component partial fractions. And we proceed in the same way. We are going to multiply each of the 4 terms by the denominator of the left-hand side. If I do that, then I'll be left with 4 minus 2y on the left-hand side, because this will cancel out. So I will have 4 minus 2y on the left-hand side. For the right-hand side, I'll do one example for a, and that will be a over 2y plus 1. All of that times the denominator of the left-hand side, which is 2y plus 1 times y plus 1 times y plus 3. And you can see that this will cancel with that, and we have a times y plus 1 times y plus 3. And so for the first term on the right-hand side, I'll have a brackets y plus 1 times y plus 3. Similarly, for the second term, I will have plus b times 2y plus 1 times y plus 3. And for the third term, that will be plus c brackets 2y plus 1 times y plus 1. So at this point, I can choose to use any of the two methods that we have learned, either the substitution method or the comparing coefficient method. On this occasion, I believe the substitution method is much easier and faster, so I'm going to use that, and I'll do my substitutions. So if I let y is equals to minus 1, then I can eliminate this whole term, because if y equals minus 1, then this becomes 0 and the whole term becomes 0. In the same way, this will become 0, making the whole term 0. So I'll be left with 4 times 2 times minus 1. That will be 6, because minus 2 times minus 1 is plus 2 plus 4 is 6. And that will be equals to b bracket minus 2 plus 1 times minus 1 plus 3. If I simplify that, I'm going to get 6 is equals to minus 2b, which implies that b is equals to minus 3. And so that's the value of b. Then if I let y is equals to minus 3, then I'll have for the left hand side 4 minus 2 bracket minus 3 is equals to, and again you can see that because y is minus 3, this becomes 0 and the whole of this term is eliminated, and in the same way this becomes 0 and the whole term is eliminated. So I'll just be left with this term to deal with, and that will give me c bracket minus 6 plus 1 times minus 2. And simplifying gives me 10 over here equals to 10c. And this implies that c is equals to 1. Now if I let y equals to minus a half, then I have for the left hand side 4 plus 1, because minus 2 times minus a half is 1. And for the right hand side, this becomes 0 and the whole of that will be eliminated, and this will also become 0 and the whole of this term will be eliminated. So I'll be left with just this term, and that will give me a brackets a half times 5 over 2. And that means I have 5 here equals to 5a over 4. And solving for a will give 4. So the values are a equals to 4, b is equals to minus 3, and c is equals to 1. Number 2, express 2 over 4 minus x squared in partial fractions. So first of all, you need to realize that the denominator is the difference of two squares. So 4 minus x squared is the same as 2 plus x times 2 minus x. So 2 over 4 minus x squared can be written as 2 over 2 plus x times 2 minus x. So now we have 2 over 2 plus x, 2 minus x will be equals to the component partial fractions, which will be a over 2 plus x plus b over 2 minus x. If I multiply all the three terms by the denominator of the left-hand side, then I'll be left with 2 on the left-hand side and a times 2 minus x for the first term, because this will cancel the 2 plus x. And then for this term, I have b times 2 plus x. Then I'll let x is equals to minus 2. In that case, I'll have 2 equals to 2 minus 2 will be 0, and therefore this term will be eliminated. And so I'll have a times 2 plus 2, which implies that I have 2 equals to 4a. And so a will be equals to half. If I let x equals to 2, then I'll have 2 is equals to, and again, this will be eliminated, and I have 4b, which means that b is equals to half. So 2 over 4 minus x squared will be equals to a half over 2 plus x plus a half over 2 minus x. This can be simplified to 2 over 4 minus x squared will be equivalent to 1 over 2 brackets 2 plus x plus 1 over 2 brackets 2 minus x. And that's the answer required. So this brings us to the end of this session on Introduction to Partial Fractions.